Okay. We should keep in mind that the independence of trials should be secured, but you need to be careful about its properties, and that's it. I mean, you need to make some manipulations to force it into binomial distributions about the natural phenomena. And now let's continue with the negative binomial distribution, where the number of trials required until a specific event occurs in the nature of binomial approach again. We will be dealing with the P and Q probabilities here. For example, time passes until getting a service in a queue, or the work time of a device until it is broken, etc. So this is what we're dealing with in this sense. And negative binomial distribution is dealing with the n trials until rth positive event is occurred. This type of questions is in our here, in our interest here in this sense. So if we denote this with capital Y, your random variable, and we're curious about the Y parameter here, the probability of that Y would be Y minus 1, Y minus R, PR, Q, Y minus R. Okay, you're curious about the rth occurrence of an event here. Your Y can be R, R plus 1, etc. It can go ahead like this. So the P is the probability of occurrence of a plus, okay, and your Q is its complement, 1 minus P, and what is Y here? It is the number of trials until the rth plus is observed. This is what we're dealing with. So if we want to, suppose that you're getting a negative, negative, positive, negative, negative, positive, and goes on like this for a long time, and you will have a negative and positive here. Now, it means that you will have your Y trials in total, Y trials here in total, until the rth plus has occurred here. It means that what you will have here up to this point will be what? Y minus Y minus R negatives here you will have, and you will have R minus 1 positives here. That's it. See, you will have Y minus R negatives here, and let me just write them like this so they will not get confuse you. Okay, so that's it. Like these are all we're talking about trials here. Okay, that's it. Normally it is denoted with probability of R and Q Y minus R, but their combinations, their coefficient is differing, as coefficient differs with Y minus 1, Y minus R here. This part is in fact different. This part is pretty similar at all. That what we're already familiar with. It could be best understood with an example, hopefully, which is taken from the book again. Like if we're trying to fix 4 screws to a tire here, as we consider that a screw is fixed at 0.9 probability in 1 second. Okay, so a trial lasts for 1 second. You're trying to fix a screw to a tire, but with 90% probability it is fixed. With 10% probability you need to do it again for 1 second again. That's the idea. Now the first part of the question is find the probability distribution for fixing 4 screws to a tire. So you need to fix all of them, right? So what is the probability distribution of this phenomenon? Okay, like y minus r PR, it's coming from our definition or formula, right? And it would be what if we put them in their locations? See, it is 4, see, because you will have 4 here, and it would be 0.9 over again 4, and it's 0.1 over like y minus 4 here. This is what we'll have. And now the second part of the question is a numeric one. For what is the probability for it to take 6 seconds exactly or 6 trials? What is the probability of having 6 trials or 6 tries to fix those 4 tires? And now if we put them in their correct locations here, what I'm curious about is 6 here now. Your y is 6, and it would be y minus 1, which is 5, and y minus r, you need to fix 4 of them, right? It's 2, and it would be this 4, this over 2 will not be fixed, and the result will be 0.0656, and it is approximately, what is it, 6% probability, okay, to have it fixed in 6 seconds. So if you're curious about the expected value of time required for fixing 4 tires, you can be curious about it. And it would be your population mean, right, as well. It would be mu y. It is denoted with r over p, and we are not going into detail of proofs here, and the variance would be, okay, square y should be r q p squared. Those would be your variance, and this would be your mean here. And for our example here, the above example here, your mu y would be 4 over 0.9. Particularly, it is 4.44 seconds is your average time for fixing all those 4 screws to this tire. And with what variance? What is the shape of this distribution? It is 4 times 0.1 over 0.3. So it would be, and this would be its variance. Okay, when you take the square root of this one, this variance, you will achieve your standard deviation in any means. So this is called the negative binomial distribution here in this sense.